Everybody, today we're going to be working on the HPI Racing RS4 Sport 3 Creator Edition. There's not much to do here, it's pre-assembled. We're going to reveal the electronics, install them, and then in the next video I'm going to reveal which body I chose and the wheels, and then we'll take it out for a test drive in a future video. So here we go. So if you watched the unboxing video, I originally wanted to use this chassis for USGT class. However, I looked into the official rules of USGT and I couldn't use the Hobby Wing combo, 21.5 combo that I already have. Instead, they require a Gravity RC Motive 21.5 motor that costs $80. And since this chassis only cost $130, I didn't feel like an $80 motor would be justified. Maybe if I get another chassis in the future, I will look into USGT again. So instead, I'm going to use my Surpass Hobby ESC and motor combo. This is a 3500 kV motor, and I'm going to pair it with the ESC I have there. And on that vein, I'm going to use just your average Amazon bought servo. This isn't the best servo in the world. It's not the fastest. It's also not the torquiest, but it will turn the wheels on this car. And I'm going to be using my DX3C transmitter, so I'm going to use this generic receiver. As you can see, I'm not going all in on this build. I looked at the chassis a little bit. I realized it has some limitation and needs quite a few hop-ups to make it race-worthy. And a lot of parts, unfortunately, are either very expensive or not available here in the United States. So I'm not going to spend too much time or money into this chassis, but I will make it look very nice. I chose a very nice body to go with it. And we'll put it together. Maybe I'll put it on the shelf. Maybe I'll put it on the track. Who knows? We'll see what happens. All right, even though this is a pre-assembled kit, there's still a little bit of assembly required. First thing we need to do is put on the foam bumper. What I do like about this kit is everything in step one was in one bag. I didn't have to go look around for it in different bags. It makes it super convenient. And this is really the way that modern RC kits should be. And of course I'm referring to Tamiya kits as somebody who does things the opposite way. So first step here is to index these posts and make sure the holes line up passenger side and driver side and not front and rear of the vehicle, like so. There's a hex shape on the bottom of the post here, and you need to make sure that they are indexed properly so that the holes face sideways. And for these is going to be the longer of the flathead screws, and we'll go ahead and put them on and make sure the posts stay aligned when it gets to the bottom. And we'll just go ahead and use a hand screwdriver, hex driver. There we go. Okay, let's go ahead and do the other side. All right, I need to turn the posts before I tighten it. And there we go. Both posts are facing the correct direction. And next step is to slip on the bumper. Then I'm going to put the top holder and put on the screws. Okay, the next step is to put these on, and this is where the Lexan body will rest. So there's a hole right there, and you want to put the pin through those holes and through the posts. But since I don't know where the Lexan body is going to rest, I'm just going to randomly put it through a hole for now. Okay, I managed to get the front post done. I am looking at the rear right now. This is the rear mount, and mine was very bent. It was pointing outward. I took it off of the chassis, and now I'm just stretching it back so that the posts can point straight up rather than outward. It happens during shipping, not a big deal. And I'm sure I'll stretch it back once, even more once the body's back on. I think the trick here is just not to snap it in half. All right. Okay, here we go. That's as straight as I can get it right now. And all we need to do is make sure the holes are lined up left and right. And they just go right in here. And then we need to line up a hole and put a pin through there. Takes a little bit of force. It's pretty tight. There's a lot of friction there. But it's manageable. See if I can get a better grip on this thing. Okay. Have them push through, just touching the bottom there. And let's see, much better. It's pointing much straighter than when I first got it. So the pins come in through the side, and I'm probably gonna have to cut until I'm done again, so you don't have to watch me struggle with pins. Let's go ahead and do that. Okay, there we go. You can see the posts are still not straight. We'll keep trying to adjust those as I get the body together, but let's go ahead and move on. Next step is the servo casing here. So I need to take this off of the chassis and mount the servo and then put it back on the body. And it looks like it is 1, 2, and 3 screws. Let's go ahead and take those off. Okay, fell right out. Looks like the 3 screws are the same size. Now let's see how this works. It looks like the receiver goes into the top here. I'll do that next, but I'll probably do it after I put it back on. The servo goes into the front here, and then the servo horn, servo saver. So let's go ahead and grab the servo. All right, before we install electronics, as always, best practice to make sure everything works. You don't want to install the servo and the servo horn, come to find out later it's not centered or it doesn't work at all. So I have everything plugged in here, and I binded the receiver to the transmitter already. So let's go ahead and test this. Okay, you can hear and physically see the servo working. See how the motor's doing. I got forward and reverse, so everything works. Let me go ahead and turn this off and mount the servo. Okay, I went and grabbed another servo. This is a more standard size servo, a 20 kilogram servo. And everything fits perfectly. There's no rubbing, no interference. Probably could have just swapped things or changed servo horns to make the low profile work. But I want to build this kit as close to the manual as possible. That's always my goal, so that everybody can learn from it. Let me go ahead and tighten this a little bit more. On the previous page, it does tell you that this kit requires a standard servo here on page 7, and I actually didn't think much of it. I thought maybe it was just so that you don't try to put in a jumbo servo in here and it goes beyond the dimension of the case. But actually the headspace matters on top of the servo as well, so that there's enough clearance for this link. Live and learn. So I'm going to put this low profile aside and save it for the next build. I like using low profile servos on touring cars because it saves on weight and space, especially in another chassis like a TT02, where the space for electronics is premium. But since they've already marked out how much space you need, and it really doesn't matter. So let me go ahead and bolt this back onto the chassis, and we'll be ready for the motor install. I still have one screw there, and let me go ahead and set that on there. And I actually decided to leave that footage in there instead of reshooting the whole thing like that never happened, so we can learn together. And prove that it's true. You have to use a standard size servo. Hopefully you watch this and you don't make the same mistake I do and save yourself some time and headache. I just happen to have a lot of servos in my box. I built quite a few kits. I keep them around and then I take them out of different kits and sell them as rollers. So I always have some electronics around. Alrighty. Go ahead and give everything a quarter turn by hand. There we go. Servo's in, and I imagine that just need to press down on this link and connect them. There you go. Pretty good fit. It's actually quite neat and looks quite precise. So I like that design. I don't really like that I have to use a standard size servo, but looking at the geometry and how everything worked out, I'd say it's pretty good, pretty worth it. All right, so no big deal. Put a little extra weight on the servo. Okay, so let's go ahead and move on to the motor. Okay, let's prep the motor first, because I am a little particular on the orientation of the motors when it goes in there. I would like the wires to be sticking up vertically, and if I need to index a little bit, I'd like it to point on the outside of the chassis rather than in like this. So I'm going to put on the motor plate. The motor plate goes on like this. It's going to go into the chassis like so. So I'm going to choose those two holes right there. And it's a little bit strange. The top screw is a cap head screw, and the bottom screw is flathead. Let's go ahead and put that in. And put in the flathead screw. Like so. If you want to put a little bit of Loctite, certainly this would be the time and place. And it looks like the pinion is not included, nor the motor, obviously. So let me go grab a pinion gear and we'll talk a little bit more about it. Okay, the pinion gear is not included, and on here they recommend a 27 tooth pinion. I have a 29, and the trick is to get it to 8mm between this collar and the top of the pinion. I don't know how close I'll be able to get, but let's just say it's right there, and I can turn this in and then make adjustments as needed before I tighten it. If you don't have a caliper, you can always just trial and error this. I think I need to go in a little bit. Let me get a better angle in this. Make it easier for myself. Okay. I think that's close enough. That's probably as close as I can get, just eyeballing it. All right, and the next step is to take off the mount that's on the chassis. So first you take off this screw right there. And this exposes the spur gear, so you can look at the gear mesh when you put the motor in there. I don't know if I can pry that off or not. And you also need to take off these two screws. Let's go ahead and use this. One. And two. And let me take this plastic piece off. There we go. Exposes the spur gear so we can check gear mesh. And the motor simply slides in. And just keep turning it until you find a good gear mesh. It's kind of tough to see. But basically you set it in like this and you turn it until you get good gear mesh. And I am going to eyeball it from experience. But you can use different methods. You can use the post-it note method. I'm going to just turn this a little bit more. Gear mesh is very important. I think that's as far as it's going to go. Okay. And then I'm going to put this back on. And the other screw. Okay. I have pretty good gear mesh and it's in there. The pinion isn't lined up perfectly. Now I can adjust it just a little bit from this angle. Let's see. Probably not necessary, but if I can make it perfectly aligned, I will. And there we go. That lines up a little bit better than it did before. And let's go ahead and put this cover back on. Actually, before I go too much further after this, I'm going to plug this back into the receiver and battery and just make sure everything still works. Really having a hard time getting this back into position. All right, I brought the electronics back, plugged it in, and let's go ahead and test the motor. All right. That's fine. And the steering servo, everything still works, left and right. Good. Let's go ahead and cover the spur gear. All right, the spur gear cover is a little tricky. It needs to go straight down, but then there's a little tab there that you need to get underneath. So let's try it a couple different ways. Let's try the tab first, but no, you gotta get that going straight down first. So straight down, tilt, and then push in. All right, that is the trick. There we go. We got the motor installed. Spur gear is covered. Let's take a look what's next. Okay, and the next part is just to go ahead and glue down the electronics and strap in the battery. Actually, I don't even see them talking about taping down the electronics at all. But let's go ahead and put the receiver in the receiver box next so that we can continue working. So there's 2 screws. I am not a big fan of servo wires that are this long. I mean, it's kind of ridiculous. I mean, I guess it's good for if this was a crawler or something. I can't even think why else you would need such a long wire. It's a little ridiculous to me. Even though this car is not going to go in the water at all. Just go ahead and follow the wiring through this. Probably keeps the dust out of the receiver box. I don't see any seals on the bottom of that, so I don't think it's waterproof anyway. But I think it will be dust proof or prevents dust. All right, let's yank that all the way in. Actually, you know what? I'm going to keep the wire outside and just have enough to plug it in. That's another reason why I prefer low profile for touring cars. These wires tend to be a little bit shorter. Okay. And let me grab the receiver. And I always tuck this wire and fold this up like this and put heat shrink on it. Let me go do that right now. I'll be right back. Okay, so all I did was fold it over the antenna wire and I put some heat shrink around it. And now I'm just going to tape it to its side like that. And for that, I'm going to use a little bit of double-sided tape. I have a ton of this stuff. Always come in handy for one thing or another. I'm going to cut a generous piece so that it doesn't come off. And that's it. Again, I don't bash my cars. I don't do speed runs. And I normally just keep my cars on a track, which isn't all that big. So I don't need a whole lot of range on my receivers. And so I'm able to get away with this. If you drive your cars different ways, then you may not be able to. But you should definitely test it to find out for yourself. I don't have any advice on that at all. Okay, let me go ahead and get this wire through, and then we'll do a little cable management later. Let's go ahead and put this on this side. If this is waterproof, I don't know why it needs to be so difficult to get this plug in here. It's a narrow space, barely the width of the plug, and I am struggling on both of them. Okay, I got everything plugged in. Okay, everything is working now. Servo's working. And I can see the motor's working, front and back. So we're ready to go. Good, unplug that. Let me just make this a little bit cleaner. I think I'm going to turn it maybe this way. Let's see if this will close. Let's see which way the lid is. The lid is over here. And the lid is like that. Looks like it will close. So I like this box and I don't like this box. I like it because it's neat, it's clean. It kind of protects your receiver from dust or dirt or whatever you got going on your track or surface. What I don't like about it is it adds weight, unnecessary weight. And if you are into racing, every ounce or gram counts, especially when you're in spec class and everybody's running the same electronics essentially. You want to be as close to the weight limit as possible, and I feel like this just adds unnecessary plastic. Okay, everything still works. So next, all I'm going to do is do a little cable management. Kind of fold these up, put some shrink wrap, let's see, put some zip tie around these, and then I'll tape this down. Okay, let me do this off camera. All right, I'm done. And all I did was basically zip tie the servo wire, put it right up against the servo. I put the ESC and sandwich it between the ESC and the servo there. I taped everything else down and I tucked in the wire so it looks more or less neater. And I wish this servo wire wasn't so long. This is kind of ridiculous. You see it's like 8 coils there. So far so good. I am neither impressed or disappointed at the kit so far. I think it's fine. But I'm done. I'm done setting up the HPI RS4 Sport 3 chassis Creator Edition. And next video, I'm going to reveal which body I've chosen for this build and also the wheels and tires. And then I'll go ahead and paint it and show you the final result in the next video as well. Thanks for watching. I hope you enjoyed it. Please give this video a thumbs up. Subscribe if you want to see more. Thanks for watching. See you in the next one.